During this segment, we will look at quadratic functions and their graphs. Now, don't forget when I use the word function, that means when I graph that function, it will pass the vertical line test. So just keep that in mind. Recall that earlier we did graph the function f of x equals x squared, or if you'd like, y equals x squared. But notice that this is a function because this passes the vertical line test. Now, in general, we will be looking at quadratic functions. What is a definition of a quadratic function? It is one that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and of course a is not equal to 0. We will be graphing by using shifting and reflecting techniques. If you did cover an earlier section on shifting and reflecting, this will just be an application of what we looked at earlier. Let's recall a few things about the graph of a quadratic function. Its shape is given a special name called a parabola. Since this parabola is opening upward, this lowest point is given a special name called the vertex. Now, if you notice, this is a sketch, but supposedly this is what we call symmetric about this y-axis, and the y-axis is called the axis of symmetry. Now, what does it mean to be symmetric about, in this case, the y-axis? It means that, for example, if I were able to fold this along the y-axis, these two pieces would coincide. So that's what I mean by the axis of symmetry. So in general, that is the graph of f of x equal x squared. By the way, if the coefficient of x squared, of course here it's 1, if it's positive, this parabola opens upward. If it's negative, the parabola opens downward. And now let's look at some shifting and reflecting, and let's continue graphing quadratic functions. So everything that we graph will pass the vertical line test. Let's look at the following. Graphing the parabola defined by f of x equals x squared plus k. If k is positive, the graph of f of x equals x squared plus k is the graph of y equals x squared shifted upward k units. If k is negative, the graph of f of x equals x squared plus k is the graph of y equals x squared shifted downward the absolute value of k units. The vertex is 0k, and the axis of symmetry is the y-axis. Now that last sentence will naturally follow if we just shift correctly. Notice I have this function h of x equals x squared plus 5. So the general shape, because it's x squared plus some constant, the general shape is a parabola, but it is moved upward 5 units. So since it's moved upward 5 units, instead of the vertex being at 0, 0, if I move that parabola upward 5 units, 1, 2, 3, 4, 5, the vertex is now right here. The shape is exactly the same, although I won't be able to show a lot of it on my rectangular coordinate system. That is the graph of h of x equals x squared plus 5. The vertex is 0, 5. Just as I mentioned, it would be 0, k. And what is the axis of symmetry? You can look and see the axis of symmetry. It is the y-axis. Now let's continue working with this. Let's compare this, say, with another function. Now this is the function what we called h of x, which is x squared plus 5. Let's compare that with f of x, which is x squared minus 1. This is a parabola. It is a function. It passes the vertical line test. But what movement does this cause, the minus 1, tacked on to the x squared. Instead of the vertex being at 0, 0, now you move the parabola down 1 unit. It's as simple as that right now. So move the parabola down 1 unit. Here is now the vertex, and it's the exact same shape as before. So just draw in. We are sketching right now. Draw in that general shape. There is the graph of f of x. What is the vertex? Well, the vertex is 0, -1, and notice that the axis of symmetry is still the y-axis. So there is what causes shiftings up and down, or upward and downward.